The mechanic had spent 27 years working with industrial machinery, repairing everything from small workshop tools to enormous manufacturing equipment that filled entire factory floors. His experience had taught him to recognize quality engineering even when buried beneath layers of corrosion, dirt, and abandonment. The opportunity to purchase the flooded mine hoist came through an unexpected phone call from a property developer who had acquired an old mining site and wanted to clear the land quickly. The developer had received several lowball offers from scrap metal dealers who saw only the weight of iron and copper. But the mechanic saw something entirely different when he first descended into the flooded shaft to inspect the equipment. The mine itself had been abandoned for over 40 years after the mineral deposits became economically unviable to extract. Water from underground springs had gradually filled the lower levels, and the main hoist system that once lifted tons of ore to the surface had been left in place when the company went bankrupt. The mechanic stood on a partially submerged platform, shining his industrial flashlight across the dark water, illuminating the massive drum mechanism and the framework of the hoist tower. The scale of the installation immediately impressed him. This was not some small-scale operation, but a serious industrial facility that had once represented a significant investment in mining technology. Before we continue with this incredible discovery, if you're enjoying this story of industrial treasure hunting and mechanical resurrection, we're incredibly close to reaching 7 Derozoran subscribers. Hit that subscribe button right now and help us cross this milestone. And if you really want to support the channel, click the Super Thanks button below to help us bring you more amazing stories like this one. Also, drop a comment and let us know where in the world you're watching from. We love hearing from our global community of machinery enthusiasts. The mechanic's initial inspection revealed that the hoist system consisted of several major components, each representing substantial value if they could be recovered and restored. The centerpiece was an enormous electric motor manufactured by a renowned American industrial equipment company from the 1950s. The nameplate, though covered in mineral deposits and rust, indicated a rating of 500 horsepower at 1,200 revolutions per minute. Motors of this size and quality were built to last generations, constructed with materials and craftsmanship that far exceeded modern standards. The copper windings alone contained hundreds of pounds of high-grade wire, and the cast iron housing had been machined with precision that modern manufacturers would struggle to match economically. Surrounding the main motor were the mechanical components that translated electrical power into the controlled lifting and lowering of the mine cage. A massive drum, approximately 8 feet in diameter, had been wound with steel cable designed to support loads of several tons. The drum itself was a masterpiece of industrial fabrication, machined from solid steel and mounted on bearings that still rotated smoothly despite decades underwater. The mechanic tested the movement carefully, feeling the quality of the engineering through the resistance and smoothness of the rotation. These bearings had been packed with special high-pressure grease when installed, and the seals had done their job remarkably well, preventing water intrusion into the critical moving parts. The control systems presented both a challenge and an opportunity. The original relay-based control panels had suffered significant damage from moisture and corrosion, but the heavy-duty contactors and switches were salvageable. The mechanic photographed everything meticulously, documenting the wiring configurations and mechanical linkages before any disassembly began. He knew from experience that industrial systems from this era often contained proprietary components and unusual configurations that would be impossible to replicate without proper documentation. His smartphone filled with hundreds of images capturing every angle, every connection, every detail that might prove crucial during the restoration process. The negotiation with the property developer proceeded quickly. The mechanic offered a price that reflected both the value of the recoverable materials and the substantial cost and effort required to extract the equipment from its flooded tomb. The developer accepted immediately, relieved to have the liability removed from his property without the expense of hiring specialized demolition contractors. The mechanic secured the purchase agreement and immediately began planning the recovery operation. This would not be a simple matter of disconnecting a few bolts and loading components onto a truck. The extraction would require pumping operations, underwater cutting, heavy lifting equipment, and careful coordination to prevent damage to the valuable components. The first phase involved partially draining the shaft to expose the upper portions of the hoist mechanism. The mechanic rented high-capacity submersible pumps capable of moving thousands of gallons per hour, lowering them into the murky water and directing the discharge into a nearby drainage culvert. The water level dropped slowly over several days, revealing the extent of the installation and the challenges ahead. As the motor housing emerged from the water, the mechanic could see that the external surfaces had developed a thick coating of rust and mineral deposits, but the core structure appeared intact. The electrical junction boxes had been sealed well enough that some internal components might have survived in usable condition. With the water level reduced to manageable depth, the mechanic brought in a portable crane rated for 5-ton lifts. The hoist motor alone weighed approximately 3 tons, and removing it safely required careful planning. He fabricated custom lifting brackets from heavy steel plate, drilling and tapping mounting holes in the motor housing to distribute the load evenly. The crane operator positioned the equipment precisely, extending the boom at the optimal angle to clear the shaft walls during the lift. The mechanic attached the lifting cables, double-checking every connection and clearance before signaling for the first tentative pull. The motor resisted initially, held in place by decades of corrosion that had essentially welded components to their mounting brackets. The mechanic applied penetrating oil liberally to every visible bolt and joint, allowing it to soak overnight before attempting the extraction again. The second attempt proved more successful as the chemical looseners did their work. Bolts began to turn, brackets separated from mounting plates, and the massive motor slowly lifted free from its foundation. The crane operator raised the load carefully, watching for any unexpected shifts or binding as the motor cleared the shaft opening and swung over solid ground. Lowering the motor onto a heavy equipment trailer required equal care. The mechanic had constructed a wooden cradle designed to support the motor's weight, while preventing rolling or shifting during transport. The motor settled into position with a satisfying solidity, and the mechanic immediately began securing it with chains and load binders rated far beyond the necessary capacity. He had witnessed too many equipment failures caused by inadequate securing to take any chances with a load this valuable and this heavy. The transport to his workshop proceeded without incident, though the mechanic drove slowly and carefully, conscious of every bump and turn. The workshop where the restoration would take place had been the mechanic's domain for 15 years. The space had evolved from a simple repair facility into a well-equipped industrial shop capable of handling major machinery projects. An overhead bridge crane allowed him to move heavy components with precision, and an array of specialized tools lined the walls and benches. The mechanic positioned the motor on a reinforced workbench, arranging lighting to illuminate every surface as he began the detailed assessment that would determine the restoration strategy. Disassembly started with removing the external covers and access panels. Each fastener received careful attention, photographed and labeled according to its location. The mechanic had learned early in his career that reassembly became exponentially more difficult without proper documentation, especially with complex equipment featuring dozens of similar-looking but critically different components. As the covers came away, he could inspect the interior condition of the motor windings. The sight that greeted him exceeded his most optimistic expectations. The copper windings, though darkened by age and exposure, showed no signs of catastrophic corrosion. The insulation around the wire remained intact, suggesting that the motor housing seals prevented significant water intrusion into the critical electrical components. The mechanic tested the insulation resistance using a megometer, applying high voltage to measure the electrical integrity of the windings. The readings indicated that with thorough cleaning and proper drying, the motor could potentially be returned to operational status. This discovery transformed the project from a parts recovery operation into a complete restoration of a magnificent piece of industrial engineering. The rotor required extraction from the stator housing, a process that demanded both mechanical skill and careful technique. The mechanic constructed a support frame to hold the stator vertical while he worked on removing the rotor assembly. The main shaft, over 6 inches in diameter, passed through precision bearings at each end of the housing. These bearings had survived remarkably well, protected by their sealed construction and high-quality lubrication. The mechanic heated the bearing housings carefully with a torch, expanding the metal just enough to allow the rotor to slide free without forcing or damaging the precisely machined surfaces. With the major components separated, the cleaning process began in earnest. The mechanic used a combination of chemical cleaners, wire brushing, and careful scraping to remove decades of accumulated grime, rust, and mineral deposits. The copper windings received especially gentle treatment, cleaned with specialized solvents that dissolve contaminants without attacking the insulation. The cast iron housing went through multiple cleaning stages, progressing from heavy mechanical removal of thick rust to fine sanding that revealed the original machined surfaces beneath the corrosion. The bearing examination revealed good news and areas requiring attention. The primary load bearings showed minimal wear, their hardened steel races displaying the smooth, polished finish that indicated proper lubrication throughout their service life. The smaller bearings in the auxiliary systems showed more corrosion and would require replacement. The mechanic consulted bearing catalogs and technical references, identifying modern equivalents that would match the original specifications while offering improved sealing and longevity. The cost of premium industrial bearings surprised many people unfamiliar with high-performance machinery. But the mechanic understood that quality components in critical applications prevented catastrophic failures and extended equipment life dramatically. Rewinding the motor windings was beyond the mechanic's capabilities and required specialized equipment and expertise. He transported the stator and rotor to an electric motor rebuilding shop operated by craftsmen who understood vintage industrial equipment. These specialists examined the motor with the appreciation of people who recognized superior engineering. They confirmed the mechanic's assessment that the windings could be restored rather than replaced, a process that would preserve the original construction while ensuring electrical performance met or exceeded the original specifications. The rebuilding shop quoted a price that seemed steep until the mechanic calculated the cost of a new 500 horsepower motor of comparable quality, if such a motor could even be purchased at any price. While the electrical components underwent professional restoration, the mechanic focused on the mechanical systems. The drum assembly required complete disassembly, cleaning, and inspection of every component. The main shaft, nearly 12 inches in diameter and 15 feet long, had been forged from high-carbon steel and hardened to resist the enormous stresses of lifting multi-ton loads thousands of times per day. The mechanic measured the shaft carefully, checking for any bending or deformation that would make it unsafe for service. The measurements confirmed that, despite its age and abandonment, the shaft remained perfectly straight within tolerances measured in thousandths of an inch. The drum surface required attention to remove the deep grooves worn by the steel cable during years of operation. The mechanic set up a temporary lathe arrangement using his workshop equipment, slowly rotating the drum while carefully machining away the damaged surface layer. The process generated enormous volumes of metal chips and required multiple cutting passes to achieve a smooth, uniform surface. The final result transformed the appearance completely, revealing clean metal with a uniform diameter, ready to accept new cable when the hoist system would eventually be returned to service. The control systems presented a different set of challenges. The original relay-based controls had been state-of-the-art in the 1950s, but were obsolete by modern standards. The mechanic faced a decision between attempting to restore the original controls or designing a modern replacement system that would offer improved performance and reliability. After considerable research and consultation with electrical engineers, he chose a hybrid approach that preserved the original heavy-duty contactors while adding modern programmable controls that would provide smooth acceleration, precise speed control, and comprehensive safety interlocks. Designing the new control system required learning new skills. The mechanic had extensive experience with mechanical systems and basic electrical work, but programmable logic controllers and variable frequency drives represented technology he had limited exposure to. He enrolled in online courses, studied technical manuals, and consulted with automation specialists who generously shared their knowledge. The learning process proved challenging but rewarding, expanding his capabilities beyond traditional mechanical repair into the realm of industrial automation and computer-based control systems. The component costs for the control system renovation exceeded the original purchase price of the entire Hoist system. Modern safety regulations required multiple redundant safety systems, emergency stop circuits, and monitoring equipment that simply had not existed when the original Hoist was commissioned. The mechanic sourced components from industrial suppliers, often purchasing used or surplus equipment to manage costs while maintaining quality standards. A variable frequency drive capable of controlling 500 horsepower cost several $1,000s, even in the used market. But the performance benefits justified the investment. Assembly and testing proceeded in stages, with each subsystem undergoing rigorous evaluation before integration into the complete hoist mechanism. The mechanic built a test stand that allowed him to operate the motor under load while monitoring performance parameters. Temperature sensors tracked bearing and winding temperatures, vibration sensors detected any mechanical imbalances, and current monitors measured electrical performance. The initial test runs revealed minor issues that required adjustment: a slightly imbalanced rotor that needed precision balancing, excessive vibration from a mounting bracket that required reinforcement, and programming refinements to optimize the acceleration curves. The sound of the 500 horsepower motor running at full speed filled the workshop with a deep, powerful hum that resonated through the concrete floor and steel structure. The mechanic stood beside the machine, feeling the vibrations through his boots, watching the precision instruments tracking every aspect of performance. The motor ran smoothly, drawing rated current, maintaining stable temperature, and delivering the enormous torque that had once lifted tons of ore from deep underground. The successful test represented the culmination of months of effort, thousands of dollars in expenses, and countless hours of careful work. The completed restoration attracted attention from unexpected sources. Industrial museums expressed interest in acquiring the Hoist for public display, offering prices that reflected its historical significance and impressive restoration. Mining companies operating older facilities requested information about the restoration process, contemplating similar projects to extend the life of their vintage equipment. Equipment dealers who specialized in industrial machinery offered substantial sums to purchase the motor and associated components for resale to facilities that still operated compatible systems. The financial aspect of the project revealed its remarkable success. The mechanic's initial investment, the purchase price plus the pumping and extraction costs, totaled approximately $12,000. The restoration expenses, including professional motor rebuilding, new bearings, control system components, and miscellaneous materials, added another $18,000. The total project cost of $30,000 represented a significant investment, but the completed hoist system carried a market value conservatively estimated at $100,000. The 500 horsepower motor alone, fully restored and tested, commanded prices exceeding $50,000 from buyers seeking premium vintage industrial equipment. Beyond the financial return, the project generated intangible value that the mechanic considered equally important. The skills developed during the restoration expanded his capabilities significantly, opening opportunities for similar projects that combined mechanical expertise with modern control technology. The documentation he created throughout the process became a valuable resource that other mechanics and restorers consulted when tackling their own vintage equipment projects. The relationships formed with motor rebuilders, automation specialists, and industrial equipment suppliers would support his business for years to come. The experience also reinforced important lessons about value assessment and opportunity recognition. Most people who viewed the flooded mine hoist saw only scrap metal and demolition waste. The mechanic's knowledge allowed him to see past the surface condition and recognize the quality engineering and valuable materials that lay beneath the rust and grime. This ability to identify hidden value represented a skill developed through years of hands-on experience with industrial machinery, a skill that no amount of academic study could fully replace. The restoration process highlighted the stark differences between vintage industrial equipment and modern manufactured goods. The 500 horsepower motor had been built with an expectation of decades of continuous service in harsh conditions. Every component had been over-engineered by modern standards, using materials and construction techniques that prioritized longevity over initial cost. The cast iron housing had been cast in thick sections, machined to close tolerances, and finished with attention to detail that reflected a manufacturing philosophy focused on quality and durability. Modern motors, while more efficient and lighter, often sacrificed longevity for lower manufacturing costs and shorter expected service lives. The mechanic documented the entire restoration through photographs and detailed notes, creating a comprehensive record that served multiple purposes. The documentation provided evidence of the work quality for potential buyers, offered educational material for other mechanics contemplating similar projects, and preserved the history of an important piece of industrial heritage. He shared portions of the documentation online, where it attracted thousands of views from people fascinated by industrial archaeology and equipment restoration. As word of the successful restoration spread, the mechanic received inquiries about other abandoned industrial equipment. Property owners clearing old factory sites contacted him to assess machinery that previous consultants had dismissed as worthless. Some of these assessments revealed additional opportunities for profitable recovery and restoration. Others confirmed that the equipment truly was beyond economical repair, providing valuable learning experiences about the factors that determined whether vintage machinery could be successfully brought back to life or should be consigned to the recycling furnace. The flooded mine hoist project also connected the mechanic with a community of industrial equipment enthusiasts who shared his appreciation for vintage machinery and quality engineering. Online forums and social media groups provided venues for exchanging information, sourcing hard-to-find parts, and celebrating successful restoration projects. The mechanic contributed actively to these communities, answering questions, offering advice, and sharing the lessons learned from his experiences. The relationships formed through these interactions enriched his life beyond the purely financial aspects of the restoration business. The question of what to do with a completed hoist system required careful consideration. Several potential buyers had expressed serious interest, each offering different advantages. An industrial museum would preserve the equipment and educate the public about mining history and industrial heritage, but their budget limited the price they could pay. A mining equipment dealer offered top dollar but would likely resell the components separately to maximize profit, ending the hoist's existence as an integrated system. A collector of vintage industrial equipment wanted to install the hoist in a private museum on his estate, offering a good price while ensuring the system remained intact and operational. The mechanic ultimately chose to sell the complete hoist system to the private collector, whose genuine appreciation for the equipment and commitment to preservation aligned with the mechanic's values. The price exceeded his most optimistic projections, validating the enormous effort invested in the restoration. The collector arranged professional transportation and installation, ensuring that the hoist would operate safely and reliably in its new home. The mechanic assisted with the installation, taking satisfaction in seeing the system mounted properly and commissioned successfully. The profit from the project provided capital for expanding the workshop and acquiring additional equipment that would support future restoration projects. The mechanic purchased a larger bridge crane, increased his inventory of specialized tools, and added metalworking equipment that would allow him to fabricate custom components rather than relying entirely on outside suppliers. These investments positioned him to tackle even more ambitious projects, continuing to rescue valuable industrial equipment from abandonment and destruction. The story of the flooded mine hoist restoration reached audiences far beyond the immediate community. Media outlets covering industrial heritage and equipment restoration featured the project, bringing attention to the value of preserving vintage machinery and the skills required for successful restoration. The coverage generated additional business opportunities and established the mechanic as an authority on vintage industrial equipment evaluation and restoration. Looking back on the project from completion, the mechanic reflected on the factors that contributed to its success. Knowledge and experience provided the foundation, allowing him to recognize value where others saw only waste. Patience and methodical work ensured that each phase of the restoration received proper attention without shortcuts that might compromise quality. Willingness to invest time in learning new skills expanded his capabilities beyond traditional mechanical repair. Most importantly, respect for the quality engineering of the past motivated the effort required to preserve a remarkable piece of industrial history rather than simply extracting maximum value with minimum effort. The 500 horsepower electric motor, once submerged in dark water beneath an abandoned mine, now operates smoothly in its new home, demonstrating the same power and precision that made it valuable when new 7 decades earlier. The transformation from flooded relic to restored treasure stands as testament to what skilled craftspeople can accomplish when they combine technical knowledge, practical skill, and genuine appreciation for quality engineering. The mechanic's success with this project opened doors to similar opportunities, building a restoration business that continues to rescue valuable industrial equipment while preserving important examples of manufacturing excellence from an era when machines were built to last generations rather than years. Before we close, if you made it this far in the story, that means you're exactly the kind of viewer we want in our community. We're so close to 7 zeros or OS subscribers, just a few dozen away. Smash that subscribe button right now and be part of this milestone. If this story inspired you, hit the super thanks button to help us continue bringing you these incredible tales of mechanical treasure hunting and restoration. And don't forget to comment below telling us where you're watching from. We have viewers from over 80 countries and love seeing the global reach of our machinery-loving community. Thanks for watching, and we'll see you in the next adventure. Tentar novamente.